Right. Hello. So I'm Charette Migneault. I work at the Computer Research Institute of Montreal. So just like Tom mentioned, we have some collaboration with different partners. Today, I will present some initial results from the standards demo showcase, the Open Science Persistent Demonstrator, which is ongoing initiative right now at OGC. So the goal of this Open Science Persistent Demonstrator is to provide a way to explore principles related to reusability, portability, and transparency around the development of prototypes. So basically, before we reach the state of products that are embedded and all that, how do scientists, decision maker, even share what they are trying? Like the algorithms they develop, the component they work with, the various software architecture, the platforms they work with, how do they transfer that knowledge so that other users can try to reuse this work and try to replicate the work. And the overall goal is to reach a higher adoption of these EO-based results and improve the impact over the society. So how do we achieve that? So the idea of the OSPD is that we will try to test some scientific workflows that have been found in literature and use them across several interoperable platforms using OGC APIs. So we integrate open data and open science, such as using OGC API processes, OGC features, the stack catalogs, and so on. So this is the portable aspect. We want to make sure that we can run the same kind of operations on different servers. And we create some workflows and deploy them using Galaxy. So why we use Galaxy is because we can reuse these workflows that are developed. We can share them openly to other users and let them explore, expand on them. And all this process is then documented over the OSF platform, which allows better communication of the scientific work. So some might wonder, why are we using Galaxy for workflows when some OGC API processes can offer workflows capabilities? And why do we use OSF for metadata and linking of processes when OGC API processes can offer these capabilities as well? And the whole reason is that sometimes you could have data scientists that want to make use of geospatial data, but not for geospatial specific domains. So how do we offer this additional capabilities, this cross-domain linking and reference and sharing to basically make the use of OGC APIs better access throughout these domains? A quick shout out to all the participants. So there, as you can see, there's a lot of people participating in this initiative. And this just demonstrates how a lot of different expertise, different backgrounds are used to try to generate these use cases and try to develop the best way to implement all of this. And there's also training material developed to help in this process of how to do best practices for sharing this kind of open science. So now let's dive into a specific use case, one of the many use cases for the Open Science Persistent Demonstrator. So I'm using the Algo Bloom use case used for water quality assessment. So this use case starts with a workflow defined using a common workflow language. And this is a standard that is recommended by the OGC best practice for Earth Observation Application Package ER. And it's basically a way to deploy an application that is developed on your end through OGC API processes. This standard offers a lot of way to define metadata, which is critical for sharing the science work afterwards, such as the reference for the scientific article, who is the producer, and so on. And then you can define the inputs, such as the area of interest, the time of interest, search parameters. So in this case, we're using the Copernicus data catalog to do a search query and obtain some relevant Sentinel-2 products. And then after that, these resulting products that are found through this catalog are scattered through a process which is indicated by the S in the diagram here. So basically, for each of those products that are retrieved, it will spawn a new process and calculate chlorophyll A, cyanobacteria, and turbidity, which are used for evaluating the water quality and algae bloom. So I'm not an expert in algae bloom. I just using the reference work for the scientific publication for that. And for each of these evaluation, some outputs with raw data, color mapping, and visualization are created. So diving a bit deeper into the one instance of this scattered process, it starts by performing a download operation for the relevant bands that are used for the different items to compute. So, and then there's a calculation step that is done with OGC process. So if we're doing the turbidity, for example, as shown is in the diagram, the B1 band at 60 meters is used and the B3 at 60 meters is used to perform some very complicated calculation that will evaluate for a good representation of turbidity detection. And then all of that is passed on to a plot imaging process, which is used for better visualization and normalization of the results. So here's an example of the use case area of interest that we use for this demo. So we can see a lake where historically there was known presence of issues with water quality. And when we take that workflow that was defined using CWL, the user is able then to run this operation on his machine to validate that the results, the applications are performing as intended. So one of the neat things with CWL and how they are integrated with OGC API processes is that there's no change at all to do for deployment. You take the CWL as is, you push it to OGC API processes using part 2. And the deployment that you get from that is a process that is exactly the same as the one you ran locally on your machine. So you're able to scale up your processing. So how do we do this deployment? In this use case, we use two different platforms, one called Weaver implemented by CRIM, and the other one called Project implemented by GeoLabs. Both are open source projects, so feel free to go and use them. As mentioned, they use part 2 of OGC API processes for deploying the workflow, and the operation is as simple as you call the CLI or the Python interface, which is just under the hood OGC API processes with the CWL, and the process is generated, made accessible with a standard representation, which can be called by then any client that support OGC API processes. So now that these processes were deployed, we can start building our workflow. So here I will switch to the, how do I exit? How do I exit this? Okay. So once we are in the Galaxy tool, we can go and select whichever process we want to use. So as I mentioned previously, this kind of platform is not only specific to OGC API processes. So you have other items such as genomic operations, some chemistry operation and so on. So you can try to work on these kind of processes, which are very specific to that domain, but also use at the same time OGC API processes, which are used to obtain the base map that you use for your initial retrieval of data for performing your operations. So once the tools are imported into the workflow, we can, for example, select this one, which is a link to the processes API from CRIM. And then we can select the specific process that is used for that use case. So all the processes are made available through the standard interface of OGC API processes. And then we can use the standard definition of the processes to basically tell the process, don't return me the raw data, because there's no point to stage that data intermediately into Galaxy. I want to pass on the reference directly to the next process, which can take advantage of that direct access and then perform the processing on its end without going through Galaxy. So I can define these operations through the way the client are set up thanks to OGC API processes and the standard how to do this. On the other hand, the server that is hosted by GeoLab, once my processing is done, I want to make sure to retrieve the results. So I can specify that I want the download, and OGC API processes tell exactly how to do that. So once all of my workflow is defined, then I can make sure to replicate all of that the way I intend to. So once this is defined, I can run it. Now, for time's sake, I didn't run it. I run it previously because it takes a few minutes. But the output that you get is these kind of boxes where you get all the references of which process was called, which data was retrieved, which one is staged if it was staged, or which one was passed by reference for the following process. And all of this can be stored inside the Galaxy platform. So basically, you have a whole history that you can replicate and that you can publish. So once the workflow is made available, then you can go into the open data sets and the histories of previous execution and share all of that through the platform that basically allows better open science for different users that want to replicate that, to have the detail which processes were involved, which platform were involved, which parameters were used, and so on and so forth. So overall, in this project, we work mainly on the Galaxy portion to start with, to have some biddable workflow. The next step is to work more on the OSF part, which is the definition of registration templates to basically share the material. So we're still working on that. And we hope that in the end, we can provide a good recommendation for OGC about the best practice on how to share the necessary metadata that is required for reproducing open science and reusable experiments. Thank you.
Thank you very much, Francis. And we do have time for a couple of questions if folks have questions about the work. It's quite impressive to see OGC API processes integrated with other processing frameworks in a common tool. And again, an advantage of a more modern API approach.
Yeah, it definitely helps a lot, because using previous operation was much harder to integrate. Users had difficulty to understand, like they are not geospatial experts, so they don't know how to query those APIs. But with the latest developments, it's much easier to share that, and the adoption is easier.
So when piping processes together, if you're doing geospatial operations and then suddenly non-geospatial operations, how much warning does the user have to where they're going to suddenly perhaps leave one realm and into another, and their data can never come back? I mean, are there issues where you're going to perhaps make poor processing decisions based on mixing metaphors? So look for a better metaphor.
Yes, that's definitely some concerns, and it's part of the experimental process in a way. So I think that's why it's important to make it as easily as possible for users to understand what is happening, because if they are struggling to even understand how to use the API, then for sure they're going to do something that doesn't make sense, and yeah, it ends up in a bad way.
Excellent. Okay. Any other questions from our audience today? No? All right. Well, then we will proceed. Thank you very much, Francis.